Okay, so we're going to look at some statistics, and in particular we're going to look at some bivariate distributions and calculate the covariance when we weight them in this specific manner. So we've got two distributions here, 3x plus 2y and 2x minus 3y, and 3x plus 2 and 2y minus 3. You'll notice there's a slight difference between these two, even though the coefficients are the same. It's just that the two distributions are weighted slightly different. Now x and y, as you can see, are our random variables, and we're given that the variance of x is 2, the variance of y is 4, and the covariance of x and y with coefficients of 1 with the x and the y is 3. So we want to try and calculate these weighted covariances in these manners. So just one technical term, covariance is a measure of association between the variables. So in this particular cases we've got two variables, the x and the y. You can have as many as you like in theory. Okay, so here we've got 3x plus 2y and 2x minus 3y. Now the formula for this is written as the covariance of aX plus by, comma, cX plus dy. That's our setup for how we've written this, and we'll see here that our coefficients are a, b and c and d accordingly. So this is our a, this is our b, this is our c, and this is our d. Now note here the minus 3 for our d. So always remember to include the minus sign in the coefficient. So here obviously we've got a hidden plus. This one we know is a plus, this one's got a hidden plus, and obviously this d is a minus. So with that set up, the formula for this is a times c times the variance of x, which we are given here, and then here we've got now a combination of 2 here. So we've got bc plus ad. So now we're using bits from both sides, multiplied by the covariance of x and y when the coefficients are 1, and then adding on to that b times d times the variance of y. That's going to be our covariance. Now this looks a little bit intimidating, but it's just a simple case of just plugging in the numbers and calculating really carefully. It's very easy to make a mistake when calculating these, so we're just going to take our time. So a and c. So a and c is 3 and 2. So we've got 3 times 2, and now I'm going to put a bracket for the variance of x. So we're given that as 2. So actually I'll put a bracket around at 3 times 2 as well, so it's nice and clear. And then we're going to add b times c. So that's 2 times 2 plus a times d, 3 times minus 3. Now our normal rules of BIDMaths will apply here, so we don't really need to include another bracket to make it too complicated. And then the covariance of x, y is 3. So whatever that comes to, we multiply by 3. And then b times d, so that's 2 times minus 3. And then variance of y, which gives us 4. Okay, let's go in one step at a time. 3 times 2 is 6, and then 6 times 2 is 12. So that's correct there, just double check that. And then here we've got 2 times 2, which is 4, plus 3 times minus 3, which is minus 9. So I'm going to change this plus to a minus. and then multiply that by 3. And then we're going to add, open the bracket, 2 times minus 3, so that's minus 6, and multiply that by 4. Okay, this one was straightforward, so we got that straight away, that's 12. 4 minus 9 is minus 5. Minus 5 times 3 is minus 15. So if you think I've made a mistake in any of these calculations, put a comment in below and we'll have a look and we'll have a check. It's very easy to make simple arithmetic mistakes in this one. 6 fours are 24 and it's a minus, so minus 24. So then that's going to give us 12 minus 15 minus 24. To my reckoning, that's minus 27. So covariance here, let's just write this up here. Covariance of 3x plus 2y, 2x minus 3y, I get that to be minus 27. Okay, now this one is a little bit different. We've got 3x plus 2 and 2y minus 3. Now it's still a linear combination, just like these two are, but here we notice here we've just got a coefficient. We don't have any y or an x or any other letter for that instance anyway. So we've got 3x plus 2, so this only involves x, so the random variable x, and we've got a 2y minus 3, so this only includes the y. So this formula here now is not going to work. So we need to use a slightly different formula for this one. So the formula this time is covariance of aX plus b. So now a and b are still our coefficients, so we've got that in the formula, but notice it's only with x here, the random variable. And then we've got cy plus d. So that's how we'll write out our formula. I'm going to write out how we do it here. So this is our input. So this will be our A, our B, our C and our D, which includes the minus. Let's write that D a little bit neater. And then the calculation for this one is A times C times the covariance of XY. Now we don't need to include the variances on these formulas because we've got these here separated, so the variance of each one multiplying out together to get our answer is not needed in this case. So now we're looking pretty straightforward. So we've got AC times covariance of XY. So A times C, that's 3 times 2 is 6. So actually I'm going to write that down as we did before so we can see that. So we've got 3 times 2, that's A times C. And then a covariance of XY, which is given here as 3. So that equals 6 times 3, which equals 18. So the covariance of this combination, 3x plus 2, 2y minus 3, I calculate as 18. So I'm just going to write that here now. Covariance of 3x plus 2 and 2y minus 3 equals 18. And that gives us the answer for our calculations of covariances in this case.